Hello everyone, welcome back to my YouTube channel. So this week I'm going to explain to you how you should answer quiz 3 questions. So altogether we have 7 different questions and let's start with the first one. Question number 1. 4.90 gram of pure sulfuric acid was dissolved in water. The total resulting volume was 200 cm cube. 20.7 cm cube of this solution was used to completely neutralize 10 cm cube of sodium hydroxide solution. Determine the concentration of sodium hydroxide. Given that the atomic mass of hydrogen, oxygen, sulfur, and sodium are 1.0079, 15.9994, 32.06, and 22.98977 respectively. To answer this question, the first thing that you need to do is you need to know what is the concentration of the sulfuric acid used in this particular reaction. So in this particular question, you were given the mass instead of the molarity itself. So from the mass, you need to know how to calculate the number of mole. In order for you to calculate the number of mole, you need to know the formula. So the number of mole is equivalent to mass over RMM. From the question, you were given the mass. So the mass of the pure sulfuric acid is 4.90. So your mass will be 4.90. So you need to calculate the RMM for the sulfuric acid. So sulfuric acid is actually H2SO4. So by using the value given in the question, you can actually calculate the RMM. So 2 times 1.0079 plus sulfur is 32.06 plus for oxygen. So oxygen is 15.9994. So from here, you should get 4.90 divided by 98.0734. So you should get the number of mole for this sulfuric acid is actually 4.9963 times 10 to the power of negative 2. So this is the first part of the calculation. So from there, we can calculate the molarity. So molarity is equivalent to mole over liter. So just now we have already calculated the number of mole, which is 4.9963 times 10 to the power of negative 2. So you need to divide with the liter. So the total resulting volume is 200 centimeter cube. So 200 centimeter cube, you need to convert it to liter. So divided by 1000. So you should get your molarity equivalent to 0.2498 molar. If you look closely to the question, it states here that only 20.7 centimeter cube of the solution was being used. So you need to calculate again actually how many, what is the number of mole or of the sulfuric acid that is being used in this particular reaction. So since you already know the molarity, so the molarity is equivalent to mole over liter. So you know that the molarity is equivalent to 0.2498, and the number of mole is what we are going to calculate, and only this much, 20.7 centimeter cube. So 20.7 centimeter cube divided by 1000. So you get your mole is actually equivalent to 5.1709 times 10 to the power of negative 3. This is how much sulfuric acid is being used in this particular reaction. So what's next? So the next thing that you need to do is you need to be able to write the balance equation for this particular reaction. So in this reaction, sulfuric acid H2SO4 is being reacted with sodium hydroxide. So you need to predict what is the product. So Na plus OH, Na plus OH minus, so this one will be H plus SO4 2 minus, right? So you are going to swap these ions. So the product that you will get is an A2SO4 plus the OH and also H, so it becomes H2O. So next you need to make sure that the equation that you make is a balanced one. So since here you already have only one Na, but here you have two Na, so here you need 2 times 2. So it happens that when you times 2 for Na, you need to times 2 for the OH as well. So you have 2 OH here and another 2 O here, and you have another 2 OH here, so it means that you have 4 OH altogether. So here you need to times 2 as well. So when you look at this equation, you can see that for every mole of H2SO4, you need 2 moles of NaOH. So we can write 1 mole of H2SO4 shall need 2 moles of NaOH, right? So from the calculation that we have done just now, you only have 5.1709 times 10 to the power of negative 3 mole of H2SO4. So how much mole that you need to have for NaOH is 2 times the same value, 1.5709 times 10 to the power of negative 3. So it's equivalent to 1.0342 times 10 to the power of negative 2 mole of NaOH. Right. So if you look at the question again, it asks you to determine the concentration of the sodium hydroxide. So now, because you already know what is the number of mole for sodium hydroxide, and you know that the amount of sodium hydroxide that is being titrated is only 10 centimeter cube, so definitely you can count or calculate the molarity. So we're going to use the same formula. So molarity is equivalent to number of mole over liter. So the number of mole that we have calculated is 1.0342 times 10 to the power of negative 2, and the volume is only 10 centimeter cube. So 10 centimeter cube divided by 1000 to make it liter. So you should get your final answer is 1.0342 molar of sodium hydroxide. So this is the final answer for the first question for your quiz. Let's move on to question number 2. Which of the description explain accurately on the H2CO3 solution? So in this question, you were asked to determine whether this H2CO3 solution is a strong electrolyte or a weak electrolyte. So if you look at this solution, you know that this is not a strong acid or a strong base. So we can say that this is, if you don't know, you may assume that this might be a weak acid or a weak base. So a weak acid or a weak base shall not be a strong electrolyte. Instead, it shall be a very weak electrolyte, whereby it doesn't conduct that much electricity or it doesn't conduct so much current. So in weak electrolytes, you need to know their attributes. So there are two main attributes for weak electrolytes. So these attributes is it shall produce small currents and it shall exhibit small degree of ionization in water. In saying that, although it may ionize in water, but it doesn't ionize completely, hence there will be very little ions inside that particular solution, hence it will be a very weak conductor, as it will not produce that much current inside this solution. Moving on to question number 3, what is the correlation between ionic strength and the conductivity of the solution? So the easiest way for you to remember is by remembering this: the ionic strength is directly proportional to its conductivity. So it means that the higher the ionic strength, means that the conductivity will go higher as well. Alright, now let's move forward to question number 4. Determine the ionic strength of solution made by mixing 0.5 molar of NaNO3 and 0.2 molar of CaNO3 too. So how are you going to calculate this is by using the formula. So the formula for the ionic strength is mu equivalent to half times the summation of the concentration times the ion, the charge on the ion square. So now what you need to do is you need to know how to ionize these two substances. So from there, then only we can move on to the calculation. So I'm going to explain one by one. So we are going to look at what is NaNO3. So what are the ions that can be produced when they dissociate? So we have 0.5 and NaNO3. So definitely you should know that Na is Na plus. So if you don't know what is the charge for NO3, since that you don't have any brackets here, so it means that your NO3 naturally will be just negative, because you have only one molecule of Na and one molecule of NO3, not more and not less. But if you look at the 0.2 mole of CaNO3 too, right? So there's a hint in the same question, because now from the NaNO3 you know that your NO3 is actually, the charge is just negative, right? But here you can see that you have two NO3, two molecules of NO3, means that your Ca cannot be Ca positive, it should be Ca2 positive. Therefore, that is why you need two molecules of NO3 to balance things out. So this one will be 2 positive instead of just positive. Alright, now, so since we already know all these details, so we can just plug in the equation here. So your mu should be equivalent to 1 over 2, the summation of things, right? So I'm going to start with the NaNO3. So your concentration is actually 0.5. So we are going to do for Na first. So Na, the charge will be positive 1. So positive 1 square. Then you need to plus 0.5 times the charge for the NO3 is actually negative 1, so negative 1 square, plus, so we are going to move on to the CaNO3, and then we are going to do it for both ions, for Ca2 plus and also NO3 minus. So right now, but you need to remember that in CaNO3 you already have only one Ca. That's why here is only 0.2, but here 0.4 is actually because the concentration, the initial concentration for CaNO3 is actually 0.2 molar, right? But since you have 2 here, so you need 2 times 2. So 2 times 0.2, you get 0.4. So 0.4 times the ions, the charge on the ions for the NO3 is actually -1. So make sure that you did this right. So after you have calculated using your calculator, you should get mu is equivalent to half times 2.2. So your mu should be equivalent to 1.1 molar. Alright, now we are going to move on to question number 5. Determine the ionic strength of solution made by mixing 0.10 molar of MgSO4 and also 0.2 molar of CaCl2. So if you can see here, this question is actually almost identical as the question for question number 4. So you should use the same formula to tackle this kind of problem. So I'm going to explain to you how you can know what is the ion that will be getting when this MgSO4 is being dissociated, as well as the CaCl2 when it's being dissociated. So I'm going to start with MgSO4. So if you can't remember what is the charge for SO4, you can always recall your sulfuric acid H2SO4, right? In H2SO4, you know that it's definitely will be H plus and SO4, that you don't know what is the charge. But since for H plus is only one H plus, right? But you have 2 here, so it means that the charge for the other substance or for the other ion must be 2 minus instead of just minus. So now you can see here that your SO4 is actually equivalent to SO4 2 minus. So since that the formula is MgSO4, means that you only have one Mg inside this compound. So it means that your Mg must be 2 positive instead of just positive, because if it's just positive here, it means that it's not balanced, the ion is not balanced out. So 2 positive and 2 negative means that the total charge shall be 0. Right, next is the CaCl2. So this is rather easy. You know that your Cl must be Cl minus, right? It's in halogens. Chlorine, bromine, iodine, all of that have -1 charge. So since you have 2 Cl here, because it's CaCl2, right? So you can assume, because you need to have the total charge equivalent to 0. So your Cl, you have 2 Cl, right? So you have like -2 here. So because you have 2 molecules of Cl, so definitely your Ca must be Ca2 plus. Okay, now you already know how this substance dissociate and what is the ion be like, so you can plug in this equation for calculating the ionic strength. So I'm just going to plug in all this value inside this formula, and we are going to do the calculation. Right, the same drill, you're just going to times the concentration and the ionic charge of each and every ion that is available in this particular mixture. So from here you get, and don't forget, here is same thing that you need to do, because it's Cl2, right? The ion is actually just Cl, so you have 2 Cl here, so you need to times 2 to the concentration, and yeah, the charge will be just -1. So it is equivalent to half times 2.0, so the final answer is equivalent to 1.0 molar. This is the ionic strength of these two mixture. Right, moving on to question number 6. What is the freezing point of 0.029 molar aqueous solution of CaCl2 given that the molar freezing point depression constant Kf of the water is negative 1.86 degrees Celsius per molar? This question is very easy and straightforward. You just have to plug in all the values that you have inside the formula. So the formula for the freezing point depression is delta F. So delta Tf, which is the changes of temperature for freezing, is equivalent to the Kf molar and the charge of the ion. So all you need to do is you need to plug in all the values given to you. So Kf is equivalent to negative 1.86 and the molality is given, which is 0.029 molar. And now you're going to find what is the ion, the charge of the ion. So what you need to do is you need to know how this thing will be dissociated. So CaCl2, right? So the same thing for Cl, you know that is halogen, so Cl is actually negative, but since you have negative 1 and then because you have 2 here, so negative 1 plus negative 1 and then Ca, your Ca is actually Ca2 positive, right? Because in order for you to balance this Cl, because you have 2 molecules of Cl here, so you need the 2 plus instead of 1 plus. So from here you know that Ca is Ca2 plus and Cl is negative, so 2 plus 1, so 2 plus 1 doesn't matter of the charge, so your I is equivalent to 3. So when you calculate this, you should get negative 1.6182 times 10 to the power of negative 1, right? So this is the delta F. So now you were asked to find the freezing point. So the freezing point of water normally is 0. So since the change of the temperature is negative 1.6182 times 10 to the power of negative 1, so it means that 0 plus negative 1.6182 times 10 to the power of negative 1. So you should get the new freezing temperature is actually equivalent to negative 0.1618 degrees Celsius. So we are now at the final question for quiz 3. So determine the boiling point of solution made of 79 grams of C12H22O11 in 100 grams of water, given that the molar boiling point in elevation constant of water, which is the Kb, is equivalent to 0.512 degrees Celsius per molar. So this question is actually almost identical to the question previously, but this one is quite challenging a little bit. You need to have another step to calculate in order for you to calculate your delta Tp. Right, just like I have explained to you before, so in any question, if the mass is given to you, means that you need to calculate the number of mole. So you need to calculate the number of mole of this C12H22O11 beforehand, so that you can further calculate the molality of this solution. So we are going to calculate the number of moles. So number of mole is equivalent to mass over Rmn. So you just have to plug in this value, which is the mass, and then divide it with the relative molar mass. So from here you get 79 divided by 3.4229 times 10 to the power of 2. So you get the number of mole for the C12H22O11 is actually equivalent to 2.30795 times 10 to the power of negative 1 mole. So next up, you need to calculate the molality of this solution. Alright, so now we are going to calculate the molality. So molality is the mole of solute. So the mole of solute that we have calculated just now is 2.30795 times 10 to the power of negative 1. So divided by the mass of solvent. So your solvent is actually water. So the mass is in gram, 100 gram, but you need to make sure that your mass of solvent is actually in kilograms. So 100 gram divided by 1000 to convert it to kilogram. So you should get your molality for this solution is actually 2.30795 molar. Right, so now you can use your formula for the changes of temperature of the boiling point, so which is equivalent to the Kb, molal, and the charge of the ion. So since you know that the Kb is 0.512 and your molality is 2.30795. Okay, so what is your I? So you know that this one shall not be dissociate completely, right? It will not. And so if that's the case, means your I should be equivalent to 1. So 2.30795 times 1. So from here you should get the changes of temperature of boiling point is equivalent to 1.1817. But make sure that this, you need to understand, this is the changes of temperature for the boiling water. So the boiling of boiling point of water is actually 100, right? So 100 plus the changes, this one is positive also, so plus 1.1817. So the new boiling point of solution made by mixing this substance to water is actually 100 plus 1.1817. So you should get the new boiling point is equivalent to 101.1817 degrees Celsius. So this is the final answer for your last question for this quiz. So this is the end of the video for this week. So I hope that this video can help you to understand more of what we have learned throughout this week, and see you again next week in the lecture and also a new video from me. So thank you very much. Take care and stay safe. Goodbye.